Let's take a look at a quick example here. I want to find the volume of the solid region given by f of xyz equals xyz over the region E defined by z equals 1 minus x squared, y equals 1 minus x, y equals 0, x equals 0, z equals 0. Okay, so what's this thing going to look like? Well, in reference to z, this is going to be parabolic. So let me see, draw some axes here. So y, x, z. When x is 0, z is going to be 1. And when x is 1, z is 0. So I know I'm going to be coming out to here and here. And it's going to be parabolic, so it's going to look something like this. And actually, because y is not in here, this is going to be parabolic all the way across, for all values of y. So it's going to be this curved surface. But on these boundaries, we have y equals 1 minus x. So when x is 0, y is 1. And this is the line that obviously connects these. So this surface is going to be 1 high in terms of z on this region. So I can kind of bring this out here. So it's going to look like this. Oh, that wasn't very good. Let's see if I can draw. There we go. That's a little bit better. It's like this sliver thing. Now I have these boundaries. Y equals 0. That's the plane along the x-axis. I cut it off there. Z equals 0, so I'm down here on this plane. And x equals 0, that's the plane that goes along the y-axis. So that really defines completely this region down here. So, or the solid region E. So this is a type 1 solid region. And D is going to be this triangular region down here. So looking down onto the xy plane, what I see is a line. So this is my region. That's D. So this top surface up here, this is z equals 1 minus x squared. So I'm looking at this. This is y equals 1 minus x. And I can see now how I need to integrate this. So I'm going to start off. Obviously, I'm going to be doing a triple integral here. And this is of the function xyz. So I'm going to integrate with respect to z first. And that's going to go from 0 to 1 minus x squared. And then I'm going to integrate with respect to y, which goes from 0 to 1 minus x. And then at the end, I'm going to integrate with respect to x, which goes from 0 to 1. So this first piece, you've seen me do this before. This is the way I think about this. I'm just going to integrate from 0 to 1 minus x squared of x, y, z, dz, which equals x, y, z squared over 2, evaluated from 0 to 1 minus x squared, which is going to be to see xy times 1 minus x squared over 2. Now my next integral is going to be with respect to y. So I'm just going to leave this like it is and take a look at part 2, which would be the integral from 0 to 1 minus x of x times 1 minus x squared over 2 times y dy. All of this with this x's, this is all a constant. So that's going to be x times 1 minus x squared over 2 times 1 minus x, because that's times, squared over 2, because that's y squared over 2. So this is going to be, x times 1 minus x squared times 1 minus x squared, all over 4, which I just took a quick break here, which you couldn't see on camera, and went off to the side and did a little algebra and figured that this was x to the 7th minus 2x to the 6th minus x to the 5th plus 4x to the 4th minus x cubed minus 2x squared plus x all over 4. So I need to integrate that. So I'm just going to get rid of the equal sign and call this part 3. And I need to integrate this from 0 to 1, all of that, with respect to x. And then it really is just kind of academic from here. You just find the antiderivative and evaluate from 0 to 1. And when you're done, you're going to get 47 over 3,360. So that's the volume of this solid. But really, kind of one of the questions we need to think about is the volume of what solid?